Hello, everybody. So let's take a break from reading the book right now and kind of go through, I guess, an exercise where we can create really small programs in C and kind of just apply everything that we've learned so far. It's also like a good practice for me personally, since uh, the only practice that I've been getting is just through copying the examples from this book. And I think it's valuable that we just do more outside of the book, just to make sure that we're comfortable with the syntax and comfortable with creating functions, passing them in, and also, most importantly, just practicing our pointers and structs so that we're ready for more advanced things. The book itself pretty much at this point is I would say like etc. So it's going to go through more advanced topics of C, but it's really not super required to actually start writing programs in general. So we can actually take advantage of this point and yeah, just write some small silly programs to sharpen up our skills before we proceed forward. Yeah, so long story short, let's get started. I'm going to create a new project. I'm just called practice. And I'm just going to write a bunch of random C programs. Just, maybe start from like the easiest and just get more advanced as we go along. Just kind of like a marathon. Not a marathon, but like, just for a good 45 minutes to an hour or so. So that's the amount of time I have. Anyway, let's just start. Import. Ooh, JavaScript. Include stdio.h. So that's our usual template. I always mess up square brackets. I'm using a split keyboard, so it just means I'm not skilled enough. Okay, so let's start with the hello world. So one thing that I always forget about is puts, because I always like to do printf, printf, printf. I always like to write hello world or any string like this. When I can actually just write it like this. I think put s here, if I do man put s, actually just, what was it? Writes a string s and a trailing new line to sd out. So the main difference is that put s or puts will just automatically give you the new line rather than the printf where you have to actually give that new line. So let's just try it out. So we do gcc main.c. Wow, cool. So that's good practice for puts. So I'm going to try and use puts more often going forward. Now let's just write maybe a simple function to add two numbers. So I'm just like randomly doing stuff. Int A, int B. So two integer numbers. I'm just going to return A plus B. But how about let's practice some variables. I'll do int result is A plus B. And then I'll just return result. So if I were to go here and say the sum of, then I'll do printf. Maybe I'll do percent, I guess it's percent I, and percent I is percent I, and I'll do maybe something like, see, 3 and 2, then call sum 3 and 2, and that should be 5. And let's just add a new line. Okay, so we compile again. The sum of 3 and 2 is 5. Okay. How about we store our sum function call in a variable, and we just output that instead. Remember, this result here is different from this result. They're in two different functions, different scope. Cool. Same result. Okay. So how about we print out some sort of input, like taking some input and then print it out. So in this case, instead of hard coding the sum here, we can do something like this. Ask the user for two numbers and then call sum to get the result. So int x, int y, and then we could do puts, maybe printf because we don't want that new line. So we do first number. Let's printf. Printf. First number. Then we do scanf. Then we do percent. I think it's the formatting, right? Percent I. And then we'll have the address of x. So the first number goes into the address. Is set basically the value that the user inputs will be the value pointed by the address of x. Second number and then we'll give it the address of y, and then we'll have int result. So then we'll change this to actually x, y. They're already integers, so we don't need a dereference or anything. They're not pointer types. They are int types. They are int types here. So x and y is enough, and then we'll just replace our sum call with x and then y. Okay, and let's see what we get. So first number 45, second number 1, 45 and 1 is 6. Let's modify that to just do plus equals. Then let's do it again. 45, 6. Okay, cool. So 51 this time because 6. Okay, so now what happens if we want to actually, instead of having a prompt, we'll have some arguments. So again, argv is basically an array of strings, hence pointer. Okay, so if we draw this out, what does char argv look like? So we have something like already I'm messing up. So we have something like char, and we have an asterisk arg v. We think about it in our memory model. That's not straight. You know what? I'm gonna try my best to make it straight. So what is up with my? Try it again. I'm losing it, but it's also pretty slow for some reason. Computer is slow. Okay, so yeah, my computer is really slow for some reason. Okay, so when I have an array of strings, so maybe kind of split more out. Basically, what we're saying is that we'll have a pointer variable called argv, and that actually points to a bunch of other strings. So then we'll have basically, I don't know, in this address, maybe here, another pointer. So let's say S1. Just think of it this way. S1, S2. So that'll be actually a char that. Okay? And then technically then S1 can be pointing to something like A right here. So if it's 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112. This one can be maybe B, another string, and then this one could be C, and another string. Okay, so we'll say this. Maybe argv starts, it's a base address. Okay, so that's 103 because it's an address. Argv is supposed to be an address. So that is pointing to basically an array of strings. So this one starts at 107. This one starts, and I'm only putting these labels as convenience. So S2 starts at 109, and then S3 starts at 111. So then this is basically something like this, the double pointer. Because if you take a look at the single pointer here, it actually points you to another pointer. And if you dereference that, that'll take you here, 107, which is the first character of the string. And then if you actually take a look at the next thing where it's 109, it'll go down to this. So technically, we take a look, there's no real variable attached to them. They're just memory addresses. So it looks more like this, basically. Oops. So that's how we can think about it. A memory address which points to the base it acts as a base address to another memory address, and contiguously it's just a bunch of other memory addresses which all point to the value somewhere in memory. That's the double pointer thing that's going on. So we need two values here. We're expecting two arguments, two command line arguments. So we have two command line arguments. We need to just first check to see if argc is 3 because the program name itself is one argument already. That's argv at 0. Argv at 1 and argv at 2 are the pointers to that string that will then be converted to integers as input for our result function. So we could do first validation. So we say if argc is less than or equal to 3, or actually less than 3, sorry, less than 3, we can say something like this. Please input two numbers. So we do fprintf to std error, and then we can say something like, please input two numbers. Or better yet, just do this. A dot out, num1, num2. That'll be our hint to teach the user how to use it. And then we could do, I think it's called exit, or just say return, I don't know, 1. Okay, so that's validation, whether or not we have enough arguments into our command line program. And now let's just take it in. So we'll have a pointer to a character. We'll say first input as string, or first number as string, because that is a string. We'll say argv1, and we'll say second number as string, we'll do argv2. Okay, now let's actually take a step back. Let's comment all of this out first, and let's just see what we are getting here, just for discovery. So we'll do printf %s, new line, first number as string, meaning the number that we're going to be inputting is represented as a string, right? Because that's what the array is an array of strings. So it's not ready to be added yet. We had to do some conversion. So, second number as string, and let's just see what that gives us when we compile. And we get this little error here to tell us how to use it. So we 34, maybe 91, and there we go. So we got our number inputs, but they are not ready to be added yet. They are not integers. They are being read in as strings. So why don't we try to convert them? So we can do something like int x equals, there's a helper function for this. It's a to I, which is not part of stdio, but part of, I think it's called stdlib.h, maybe? Let's see. Yeah, a to I. So what does a to I do? Converts a string to an integer. So we can just do a to I, first number as string, then we'll do the same thing for y, a to I, second number as string. Okay? So far so good. Then we can get rid of these here, and we can get rid of this here. We could also get rid of this here, and then we'll have a result, and then we'll print f with these two integers converted from the string as result. So let's see. Great. I think that's right. 34 plus 91, 125. Yeah. So that's how we take in command line arguments at a basic level. And that's how we actually convert a string to integers. Cool. So what's next? Let's actually do some pointers. Okay. So suppose now we say that we want our result to be stored as a pointer, and then this is actually a void. How will we do that? So we can't return anything, so we'll implement something here. Okay, so now this is what we need to change. Change everything below. Okay, so our result is no longer returning anything. Or sorry, our sum function call is no longer returning anything, but we need a third parameter here, and that is actually going to be what? A pointer type. So we want to be able to store our result computed from a plus b into this third argument here. Since we cannot return anything, we can do our best to actually do a plus b and then store that value as the value pointed by the third argument. And we can even say something like c, just to not confuse ourselves. So we'll just basically do, okay, dereference c, whatever the value pointed by c, update that to a plus b. Why don't we need this on a plus b? Because they are not pointer types, they are integers. But c is a pointer type, and we want to update the value pointed by c, so then we actually do star c. We dereference c and then update that. So we'll do that. And then this one here, what do we put? Well, let's actually declare something that will hold our value. So we can say int result. Okay, so pointer to an int. And then we'll actually pass that in. Okay, or we can do something like this. Result. And just pass in that address, similar to how scanf would do it. And this gets us a pointer back. So this is technically like int result 0 or something. So let's see how that works. So we're just dereferencing the pointer, assigning that value into that, and then we can just, by the time this is done executing, we've already updated the value pointed by this address of result, and we could just directly print out the integer because we've already defined it as an integer. We just basically pass in the address here. So let's see what happens. Okay, it's the same thing. It's the same effect. So let's do 1 plus 1. That's 2. So we have a little basic calculator. Pretty cool. Yeah. So let's see how that actually works in terms of like the whole memory thing. So um, basically, here's our memory, and then let's just again this is just like arbitrary like addresses. They're not really real. Technically, integers are 4 bytes, so they are 4 addresses off. But I don't have time for that. So 100. Let's just put it out here. 100, 101, 102, 103, 104. Because like 4 bytes would be like, and I'll just split all these out. It's just too much. 106, 107, 108. Okay. So then the function here is going to be void. Oosh. There is something wrong here. I think my edge is just taking up so much memory after being on for so long. Void sum. You know what? Let's just do it from here. Okay. So first let's just start from here. We declare x, for example. So int x, okay, to be let's say 3, and then we declare int y to let's say be 4. Okay, what we're going to do now is we are going to declare an int result to be whatever. I think by default it's 0. So these 3 integers, see, 1 integer, 2 integer, 3 integers. We're going to call sum, and remember, every time we make a function call, we pretty much allocate some memory specifically for that function. That's the way to see it as. So we pass in x, y, and the address of result. Cool. So int a. Oh, my tablet battery is low. That's why I feel slow. Okay. Int a is going to be a copy of x because x is here. So that'll be 3. Int b is going to be the copy of y, which is going to, yeah, right there. So that's going to be 4. And then we're going to get the address result and copy it into our pointer to an int called c. So what is the address of result? Well, it's not this. This is the value result. Let's get the address of result, which is 102. So we have 102 here. Cool. All right. So now we'll just work on this. So we'll actually end up with dereferencing C, which is here. So 102 means, so we're dereferencing. We're going to go all the way up here. And we're actually going to update that to be a plus b. So a plus b, 3 plus 4 is going to be 7. Okay? Then when we're done, we've basically now exited from the function, no returns. So this memory gets cleared. You kind of get, you get the idea. But that's basically the gist of this little calculator program here. So, okay, let's do our next exercise. How about maybe, I don't know if this is gonna work, but let's pass a string and I don't know, maybe let's pass a string in and maybe reverse it. Okay, so a string with already characters, and let's just reverse the string. So let's make a function, and we'll reverse it in place. Well, actually, we'll do 2. We'll create a copy, and then we'll reverse it in place. Let's just do 2 problems. Okay, so I'm going to just delete all this, and then I'm going to instead I'm going to prompt. You know what? Let's just start over. Okay, I'm going to prompt first. We'll create several versions. Prompt and then arguments only. So, yeah. So let's take a buffer. Let's make a buffer to hold our string. So let's do this. Buff. Let's just make a string of at most 80 characters as always. And then that'll be an empty string basically. So buffer of 80 characters. And then what we're going to do here is we're going to ask the user for some input. So print f, what is your string? Okay, space. Then we're going to scanf. I think it's basically, there was like a format to this. I forgot what it was. Scanf. It's like 80s or something like that. Um, is there examples? Let's see. Let's do it. Scanf fixed amount of characters, maybe. Oh, percent. Okay, percent 80s or something. Percent 79 because we need the null terminating character, I think. So we do scanf. And scanf returns the number of inputs actually read in. So yeah, I think it's the null terminating character is not free. So I'm just gonna assume that. I'll just scan 79 characters. Yeah, I'll just do that. Whatever. Okay, so percent 79s. Okay, and that's going to be buff. So this is, remember, but our character array is essentially, you can just think of it as a character to a pointer, or a pointer to a character. And so if it's already a pointer, we can just pass it in like this without getting the address. It's already pointing to the first character. So just for sanity, let's print out what we have in buffer. So we'll do that. Buff. And let's just print new line. Okay. Oops. GCC. Okay, a dot out. Okay, what is my string? I'll say hello, hello. Okay, how about hello, hello? Okay, so it's by spaces. That's how scanf works. Okay, so what are we gonna do here? Well, we want to reverse our input, assuming that the string is only like there's no spaces in our string. So let's actually write a function that will reverse our string. Okay, so I'm thinking let's not do it in place just yet. Let's just create an entire buffer maybe, and just um, reverse it that way first. We'll copy it, we'll reverse it, we'll return it. Okay, so let's just say we want to return a pointer to a character, which is going to be our reverse string. We'll reverse. We'll take in a pointer to the character, so we'll do original. So that's our API here. We're going to take in a string, which is why the argument is here. We're going to reverse it and return that reverse string. It's not going to be the same string. This can be a new buffer that we're going to allocate. So what's our algorithm? It's just basically you take two pointers like in the loop and you just keep swapping them until the pointers meet up. So we know that, so we need to get the string length. So we'll say, let's do this. Int len. It's going to be strlen. Is it strlen? Let's see. Well, we have to include string.h every time we work with strings. Is it strlen? Yes. Okay. So we'll do original, and that'll get us the length of the string. So we want to go from the first index to the length of the string minus 1 because it's zero-based index, and we're just going to keep swapping. But we need to also create a new buffer. So result is going to be 80, or let's say reversed. Okay, we're gonna say that's going to be 80 characters. because that's the maximum. Or do we really want it to be 80 characters? We already know the length of the string. So should it just be len? Maybe, right? Because if it's like 10 characters, we know it from strlen. So we can just say, reversed is a buffer of len characters. So create a buffer of len characters. Okay, so then we'll have a basic for loop. In this case, for int I at 0. And I think the syntax is this to declare both of them. Len minus 1. Now, this is, I'll just, stay with me. I is less than or equals to j. So while both while I is less than j and j is greater than I, okay, we want to keep doing this where we move the pointers converging, but every time we move the pointer, like basically the pointing at the indices, we're going to swap the characters. So we'll do I plus plus because we want to move I to the right, and then we'll decrement j, moving j to the left until they converge. Okay, and then we're gonna take the current index. We're gonna keep a temporary character. So char t is gonna be original at I because we're gonna replace I. Okay. Well, actually, let's copy first. That's what we wanted. Ugh, it's messy. So let's copy first. So for int I is 0, I is less than len minus 1, or len, because, okay, and then I plus plus, and then we're just going to say reverse at I is going to be original at I. Okay, no more. We don't need original anymore. We have our string now. So at this point, we're going to be reversed at I, and then we're going to replace the reverse I character because we are already storing the reverse at I into character t. So then we'll just change that to be j, and then reverse j is going to be t because that's the original reverse at I. So then we're just kind of just doing this motion here. Okay, swap, move, swap, move, swap. Now, I started at len minus 1. I don't think that is correct because that's the last element of our string. The problem with that is that the last element of our strings are null terminating character, if I believe that, if that's correct. So what I need to do is I need to start at len minus 2, and then actually at the very end, when I'm done reversing the string, I should still have that null terminating character still intact because I started one character before that and started reversing. So maybe, and I'll return reversed. Even though reversed is declared to be an array, it's still technically a pointer to a character. So this, I believe, is our reversing algorithm, string reversal. Let's just try to see what happens. So we'll have our buffer here at this point. Maybe we'll just reverse it this way and we'll print it. So we'll say printf reversed is this, and then we'll say reversed or reverse buff maybe, and let's see what happens. Oh, what? Wait. Warning. Function returns address of a local variable. Oh, that's right. That's right. That's right. That's right. That's true. We have to. So here, remember how I said that we blew away memory of the function? This is a problem because we are declaring an array here, basically, some memory inside that function space. So basically, we're declaring memory here, living inside here, this array of characters. Let's just say there's a lot of memory address. It's all in here. Now we can return, but we're returning the pointer to it. Right? So, we have a pointer here, right? That points to this contiguous block of memory for all the characters in the string. But when we're returning, we're not returning this contiguous block of characters that represents a string. We're returning the pointer. Now, when we return the pointer, all this memory gets blown away. Therefore, we lose the entire string of characters. So that's the reason why I believe that C tends to, these string methods or functions always, instead of having just one, we call it one argument. It's always like two arguments, kind of like this destination or something, right? So it's like original, dest, or I guess I would say result. And you want to store it into the result. So in this case, I don't need this. I don't need create buffer. I'm going to pass that in. I'm going to assume that the buffer is given to me so that this way, whatever we passed in still lives outside of the function. So in this case, now, say result at I, and I'll just return the pointer result. So I'm making mistakes, but I'm figuring out what's wrong. So this is good. Okay, so now we've tweaked our function to receive a pointer, basically an array of that leads us to a buffer of characters that we can use to store a result. In this case here now, if we're just going to copy over the len here, we have to make sure that we end our result now, because now we're not guaranteed anymore. Like, this buffer could be empty, and we don't know where the null terminating character is. So we have to do len -1, which is the last character of our buffer, to be, in this case, null terminating character. We have to keep that into consideration when we copy that string. But then what if we're going to start at len -2, we keep that intact, I think. So we need a buffer, a result buffer. So we'll just make yet another character buffer called result. Doesn't have to be the same name as up here. There's just two different places. And then we'll pass in result here. And then we're returning back the pointer, so that's fine. And now, yeah, hopefully. Yeah. Ooh, we're missing one character though. So we did start it too far. So here, you see this? It's supposed to be, so instead of len, so we had to start at len -1? And this might have to be len? Maybe? What does strlen give us back, actually? I'm curious, man. Strlen. It might have been giving us back excluding the null terminating byte. I forgot. So the reason why we were one off is because strlen, which is finding the length of a string, doesn't take in consideration of the null terminating byte. So we had to add 1 to whatever strlen returns. So I was kind of on the right track. I just keep that the same. Let's keep that the same, but let's actually do a +1 here because it doesn't take into consideration of the null terminating byte. And then, so right here, the strlen function calculates the length of the string pointed to by s, excluding the null terminating byte. So let's just compile again, run, hello, ole. Okay, how about this? C is fun. Nuff CC. Okay, let's do another one. ABC, XYZ, ZYX, CBA. Okay, so yeah, our thing only handles like not like I guess spaces, strings without spaces. Yeah. Okay. Now, I wonder if actually returning a pointer is even necessary at this point, since we're already passing in our pointer to a character. So if I just deleted this, for example, and then I change this maybe to avoid, and this now is just a separate call. So let's just do this. Maybe right there. It's like assign buff. So consign result. The reverse string is going to be stored in result. Because of that, I don't need to return anything. I can just print out result because result should have the reverse string at this point. Yeah, so it takes in a pointer already, and we're already modifying all this. I wonder what happens. Same result. So we didn't need to return anything because we're already modifying the pointer in this case. So it was not necessary to actually return stuff. Cool. Yeah. So that's why we need to provide a buffer because we're gonna lose that memory once we exit from the function. Alrighty. What else? Okay, let's do some dynamic memory. Let's do some malloc for fun. But I don't know how much time do I have. How can I tell how long I've been recording? 40 minutes. Okay, I have some time. Okay. So actually instead of that, let's take into consideration strings with spaces. Let's do that. And I think we don't use scanf for this. We actually use another function that actually handles consuming all characters and stopping at the new line. So that would probably be, I think, fgetS. Let's check out the man. fgetS. fgetS reads in at most one less than the size characters from the stream and stores them into the buffer pointed by S. Reading stops after an EOF or new line. That's the one. If a new line is read, it is stored into the buffer. A terminating no byte is stored automatically after the last character of the buffer. Reads in at most one less than the size characters and stores them into a buffer pointed by S. Okay. If a new line is read, it is stored into a buffer. Okay, so new lines also make it into the buffer too. So a new line and a null terminating byte are both going to be in that string input. Okay. Now that presents a problem because when we're reversing, we're assuming that the last index is the null terminating character, but then we're gonna have that new line byte. So we're gonna have to replace that new line with probably another null terminating character. So let's adjust because this is gonna throw us off. If we're gonna reverse a string, for example, let's say hello again. Okay, we start from here and we start from here. What's happening is that we're gonna end up with a string that looks like this if we're not careful. We're gonna have a new line and then the string, which is not quite right. So I think, instead of assuming now two indices back right here, let's just find where this occurs in the string and overwrite it with a null terminating character so that it looks more like this. Okay, let's see here. Okay, so let's do that. This way, we could actually have spaces. Ooh, we can actually have spaces in our input, something like this, in a white space, this, C, and then new line, which will be like this. And then we could just reverse that with the spaces. Okay, so first, fgetS. So in this case, we don't need the scanf anymore. We need the fgetS. And it takes in get a new line terminated string from a finite length from stream. So what's the input? It's hard to tell. It's gonna be what? Okay, so we have to specify the size and the size are since we're automatically inputting the null terminating byte, we just include the full size of the buffer. Okay, and then I guess this is will be stdin, and this will be this buffer that we want. Okay, just try it. So it'll be buff. Uh, the size is 80. Stdin. Okay, let's actually print that. Print our buffer. So that's what I like to do. Printf buff is going to be buff. Then what is your string? Hello world. Hello world. Okay, that handled it. That's good. But it looks like we got some characters. I don't know if that's right. Maybe. Okay. So, what is the, I guess, what is that function called that actually detects the first, like it returns us back the index of the first occurrence of a specific character? That's stirchar. So we can use stirchar to get the index of that new line character and we'll just replace it with a null terminating byte. So we can say this, index of new line character is going to be stir char. Okay, the string that we want, which is buff, and then the character that we want to check for. Okay, so stir char will give us that. And what does stir char return? Like if we get an integer, but then like what happens if it doesn't find anything? It returns a null pointer. So it's returns a pointer to a what? A pointer to a char. It's not an int. So it gives us back the location of that. The location of the address of where that new line character is. So since we had that, we can check for null pointer. If index is not equal to null, okay, then we can dereference that and just assign it to a null terminating byte. Because again, this is just a base address. This is a base address of somewhere in our buff. It could be in the middle of buff. And then we're just dereferencing that and assign it to as a null terminating byte. So then our string stops. Okay, cool. And then I think Sterling will just kind of count until the null terminating byte. So that's fine. And then that's it. I don't think we need to modify much else because everything should stay the same in this case. Let's see what happens. Yeah, looks nice. That works. This type of sentence. I am an average developer. There you go. Yeah, so that's the time I have for today, but we're gonna keep doing this. Let's do more pointers, let's do more structs, let's do more like algorithms like this. This is fun. So yeah, next time. See ya.